distribution of air pressure. If we have the distribution of the air pressure, we have the two distribution of the air pressure. So one is the vertical distribution of the air pressure and horizontal distribution of the air pressure. If you observe about the vertical distribution of the air pressure, so lower levels of the atmosphere have the very high density. The lower levels. So lower levels of the atmospheric pressure have the high density. So when you go for high density, because high layers they have the less compressed and they have the low density at the low pressures. So that's why actually when we go for the distribution, vertical distribution, which means the column of the distribution of the atmospheric pressure is known as vertical distribution of the atmospheric pressure, means in the lower layers to upper layers. So the lower layers to upper layer. So the lower level area we have that high pressure, then upper layer areas means when you go on high altitude, atmospheric pressure will be decreases. So this is about the vertical distribution. So the vertical distribution when you go on high altitude is when you go away from this earth surface. When you go away from the earth surface, then it is called as it is vertical distribution of the atmospheric pressure. Then actually this pressure when you observe, it is decreases with increasing in altitude, because from the mountain region, suppose for example, so this is about earth surface. When if yes, generally atmospheric pressure decreases when you go on high altitude, but it does not decreases at the same rate always. Then the temperature of the air, the amount of the air, water vapor present in the air, it is a gravitational pull of the earth determine the air pressure given place and given time. So it is also the based on the temperatures will be there. There is also the high altitude here. When you go for the atmospheric pressure and the sea level, so generally the normal atmospheric pressure, the rate of atmosphere decreases at the pressure 34 the millibars per the 300 meters. It is increases on the high altitude. When you go on the high altitude, look at now. So when you go on the high altitude on the mountain ranges or anything, see 34 the millibars per 300 meters, it will be decreases when you go on high altitude. So this is about mainly we'll call as the vertical distribution of atmospheric pressure. The next one, horizontal distribution of the atmospheric pressure. Horizontal distribution of the atmospheric pressure is nothing but it is more around the globe. So when it's more around the globe, suppose when you have this is the globe, atmospheric pressure is moving around the globe from one direction to another direction. I mean the high pressure to low pressure area. So this is called as a horizontal distribution of the atmospheric pressure. Actually shown the maps with help of the isobars. So it shows the isobar means what are the area, the equal amount of the atmospheric pressure is there. If we can draw that, the name is called as the isobars, there is to be drawn. So this is about horizontal and vertical distribution of the atmospheric pressure. Now what are the factors responsible for the variation in horizontal distribution of the atmospheric pressure? First one, if you observe at air temperature. If you observe the air temperature generally, so there is an inverse relationship between atmospheric temperature and atmospheric pressure. So there is an inverse relationship between temperature and air pressure. Suppose wherever the very high temperature, the automatically atmospheric pressure is low. Where the temperatures are very low, that high atmospheric pressure when we have. So this is about the inverse relationship between pressure and temperature. The next one, higher the air temperature, then automatically the lower their pressure. So this is about how the inverse relationship between. According to this one, air pressure, when you go for atmospheric air pressure is very low in equatorial region. So equatorial region, we know that equatorial region directly sunrises fall on the earth's surface. If the directly sunrises fall in this region, we can see that very high temperatures. See in this, when we go for the very high temperatures region in this one, automatically low atmospheric pressure. So this is about how the air temperatures. Then the earth rotation. The second factor is earth rotation. So earth rotates is generally when you go for centrifugal forces. So this resulted that deflection of the air from original place and causing the decreases of the place. It is original place to decrease. Again, it we believe that low pressure belts of the subpolar region and high pressure belts in subtropical regions. So created the results of the earth, the rotation. Similarly, the two important things we have to be observe it, the high pressure belts when you go for, say polar high pressure belt, then subpolar when you go for the, say polar when you go for the low pressure belt to high pressure belt, how the result used to be when. Next one, earth rotation also causes convergent and divergent moving of air. Convergent and the divergent movement of the air. See, air is when you go for the convergent experience low pressure area to the out. See how it will be experiences here. See if you observe, see if you have, this is the globe. When you have the globe, see this is about the north pole and this is the south pole when we have, say south and the north pole regions. We know that how the temperature in this region, very high temperature. So low atmospheric pressure when we have. Then when you observe about the Tropic of Cancer or Tropic of Capricorn, in this region automatically we have that compare with this equatorial region, as due to this one what will happen here, high pressure, then winds will move from high pressure area to the low pressure areas. The same thing, the high pressure area too, it will move toward that here when we go for the low pressure areas. When it's moving from high pressure area to low pressure, look at now here automatically it will go the divergent, and in this region we have the convergent one. See convergent and divergent region. See atmospheric pressure here depends on the rotation of the earth. When this rotation of the earth, what is happened, there are two directions we can see. So it is moving to the one side, it's moving high pressure to the low area, again high pressure to the low pressure it's moving. The same way the polar high pressure area to the subpolar low pressure area, the winds are moving both in the northern hemisphere and southern hemisphere. So this is the word mainly. So due to the earth rotation, this areas of convergent and divergent will be there. So the divergent is divided into the two, and when you go for the convergent, it's different direction, it is coming from the two direction. The next one, pressure of the water vapor. When you go for air with higher quantity of the water vapor, if you observe about the higher quantity of the water vapor, have the lower pressure. The same thing, the lower quantity of the water vapor have the high pressure areas. So this is about how we can. Again in the winter, the continents are relatively cool and tended to be develop high pressure centimeter. Suppose generally if you observe a ice cube, in the ice cube we know that the temperatures are very less. When the temperatures are very less in the ice cube, we know that high pressure will be there. Even there is called as a based on the water vapor is developed the high pressure. Again in the summer, if you observe the oceans and everything, we know that the low pressures will be there because temperatures are more. But the oceans are associated with low pressure in winter season, then high pressure in the summer season. So that is mainly the differences between the land and water. See on the land what has happened, in winter season we have the high pressure, summer season we have the low pressure areas. But in oceans, winters is when you observe the low pressure in winter season, high pressure in summer season. That's the mainly differences we have to be observed between land and the water. So this is about the pressure of the water. When we go for the pressure of water vapor, how we get the pressure of water vapor when we have. So this is about the next one, the pressure belt. See atmospheric pressure belts here. So there are different atmospheric pressure belts we have. If you observe about the different atmospheric pressure, how mainly there are 4 types of atmospheric pressure belts we have. What are the 4 types of atmospheric pressure belts? First one, we know that equatorial low pressure belts. We know that this is the areas when you go for the equatorial low pressure belts. Generally, how is the temperature on the equator? As the temperature is very high, but pressure is low. So it is called equatorial low pressure belts. See, equatorial low pressure belt generally is extended from the 10 degrees north to the 10 degrees south, means either side of the equator. So it is either side of the equator, it is extended from 10 degrees north to 10 degrees south. So it is about tropical, if you observe, about equatorial low pressure belts. So this equatorial low pressure belt generally it is called as a intertropical convergent zones. Intertropical convergent zones. Why it is called as the intertropical convergent zones, which means we know that, see how it is intertropical convergent zones. Look at now when you observe about this picture on this globe, high pressure area to low pressure area, again high pressure area to low pressure area. So that's why this zone is called as a intertropical convergent zones. Intertropical convergent zone, which because from high area to the low areas generally it will be moving. That's why equatorial low pressure belts generally is called as a intertropical convergent belt. So this is about the first one. Second one, tropical high pressure belts. Tropical high pressure. Generally the tropical high pressure belts extended 23.5 north to 35 degrees north and 23.5 south to 35 degrees south. Means we have the two different one. So northern subtropical high pressure belts and southern subtropical high pressure belts. So this is about the mainly here the two direction, the northern hemisphere and southern hemisphere, but is extended 23.5 degrees to 35 degrees in north and south. Then this one generally subtropical high pressure belts. We know what is generally the direction of the movement. We know that the high pressure area to low pressure area. See now subtropical high pressure area to subtropical low pressure area means equatorial low pressure area. This is the direction of the winds. So this is the direction of the winds. High pressure area to low pressure area. Again high pressure to low pressure in northern hemisphere. Then high pressure to low pressure in southern hemisphere. But this one generally when pressure is moving, even it is easy for sailing and everything. When it is easy for the sailing and everything, when are the people in the olden days, the horses they used to be travel, they used to take the horses in by ship and everything from one places to another places. When the one places to another places when it's traveling, so during the time what is used to happen, whenever the direction of the winds changes. So due to the other reason, if the direction of the pressure means atmospheric pressure is changed, when atmospheric pressure is changes, what they used to do, the horses they used to be throw it into the ocean or the sea. So that's why generally this subtropical high pressure belts they used to call it as the horse pressure belts. You understand why it is called as a horse pressure belt? That's the second one. Then third important one, if you observe, subpolar low pressure belts. Subpolar low pressure belt. This subpolar low pressure belts is extended from 45 degrees to 66.5 degrees in north and southern part. So that's why the subpolar low pressure belt, north subpolar low pressure belts and the south subpolar low pressure belt, it is extended from 45 degrees to 66.5 north. Means generally it is called as a 45 degrees to up to the Arctic Circle and 45 degrees to up to the Antarctic Circle in southern hemisphere. So this is about how it will be extended. And this one is mainly the direction of the winds. If you observe here, we know that subtropical high pressure area to polar low pressure areas. Here also the same the direction we can see here. See, this is the way direction it will be moving, and even from the high pressure of belt to low pressure area. See here generally we can go for the same thing in this part, and this is the area when you go for means we have the convergent way. So the next one when you go for the divergent also when we have the next and the last one when you go for the polar high pressure belts. Again So based on the temperature, if you observe how the temperature in the North Pole and South Pole is very low. So when the temperature, we already know that the inverse relationship between temperature and atmospheric pressure. In the North Pole and the South Pole means Arctic Circle to the 90 degrees north, Antarctic Circle to the 90 degrees north. Here the polar high pressure belts are extended. So North Polar high pressure belt to the South Polar high pressure belt. So these are the four. So based on this one, if you observe, in this part we have the convergent one. Then this is the reason when we have the divergent, means both in northern hemisphere and southern hemisphere. Once again, here we have the convergent in areas between the mainly, if you observe, the polar high pressure belts to western. Even this one also, when we call, generally we used to call as the different areas. Then in this occasion we have to be discussed the one more important thing here. So what we have to be discussed here, see, we have to discuss some of the other important thing. What we have to discuss, please observe it carefully. Between what are that, this is the areas we can call the western line, and we go for the north strait, and we go for the south strait, and the western line when we have. So generally, from the which direction its movement of the pressure, this called. Even in this occasion, we should be remember what is the cardinal, north, south, east, and west. So what are the winds as moving from the direction? Suppose this one we used to call as the eastern line, because it's coming from the east, so it is called as the eastern line. So that's why it can call the northeast. It's coming from the northeast. That's the northeast trade winds. This one also, if you observe, it is a southeast. It is coming from the southeast direction. That's why generally this one is called the southeast, the trade winds. Again, if you observe the western, it is coming from the western one. It is called as the western line. Again, if you observe about here, this one also is coming from the west. It is a western line. Again, if you observe the polar, if it is coming from the eastern, means it is come from the eastern direction, so it is called as the eastern line. So this is about mainly the four important atmospheric pressure belt. So equatorial low pressure belts, subtropical when we go for the high pressure belts, the subtropical high pressure belt means subpolar low pressure belts, and the polar high pressure belt. So this is about the atmospheric pressure belts and what is the direction. Now we'll go to the climate, climatic winds and monsoon winds. If you observe about the climatic winds, also is known as the periodic winds. Actually, these winds, it changes the direction along with the change in the time or change in the climate. So climatic may change according to the time, and according to the direction it will be changes. But here, if you observe about the land and the sea breezes, the monsoon winds are the typically examples of the periodic winds. In monsoon winds, we know what will generally change. Suppose in Indian monsoon, if you observe, there are two types of the monsoons when we have. So the northeast monsoon seasons when we have. So northeast monsoon season, mid-June to mid-September. Then we have the southwest monsoon season. This is mainly the periodic or the climate, based on the climate, this will be the changes. Even monsoon wind, also the seasonal winds, it is characterized by completely reversal in that the distribution from the one season to another season, it will be distributed. So this is about the mainly thing. Again, they blow from the sea to the land in the summer season. Again, it's blow from the land to sea in winter season. So this is about the climatic winds or the periodic winds what we have. So this is about how when we go for the winter, the seasons and all. So this is about that, about the climate winds and the monsoon wind. The monsoon, best example we can taken as a North Pole, it's a northeast monsoon and southwest monsoon season. This is about that climatic winds and monsoon season. Thank you.